Good day, everyone, and welcome to this session on DevOps, which is defined to be programming discipline. I want you to consider the situation where you have 200 plus developers, 20 plus agile teams, over 100 deployable components, and of course, the production issues that we face day in and day out. What do you have? At best, DevOps is going to be managed chaos. During today's session, you will learn how to manage that chaos. I'm going to briefly cover who I am and then get into the meat of the presentation, which will be about why do we need programming discipline, what is programming discipline, and most importantly, how you can achieve good programming discipline. And we can kind of put this in the context of a typical user story that as a DevOps practitioner, I must do what so that why. And we'll cover the why, of course, before the what. So who am I? I currently support a project that has over 100 deployable components. So the first slide you saw is my reality. I have over 20 years of DevOps experience. And to some extent, I was doing what we call DevOps back long before DevOps existed as a discipline. I'm a full stack developer, so I've done everything from systems integration to websites. I've worked in multiple countries with many different technologies. I've been with Cognizant Softvision for 15 years, and I've included my email in case you have any questions that you would like to follow up with afterwards. We will be have a session at the end of this for questions and answers. So please put your questions into the chat window and we'll take care of addressing those when we're done. So the first question, as I said, is why should we do it? We have to answer the question of why we want to have programming discipline. And the reason is that we want to achieve a high level of responsiveness to our customers, which are both our internal development teams and the actual users of the system, and maintaining a high quality of high goal of quality. There are things that get in the way of doing this. There are impediments: fatigue, repetition, and change. And we'll talk a little bit about more of each of those. Although I'll be sharing with you a lot of concepts today, the actual instances and implementations belong to our clients, so I cannot go into a lot of the detail of how it's done in our for a specific client. So the first thing we want to talk about is fatigue. Excuse me. There's many different things that lead to fatigue, and when we are more tired, we tend to make more mistakes. First of all, we are human. I know that it sometimes seems we do a superhuman effort, but we are fallible like anyone else. We have critical production issues, and when those are going on, it tends to make it more difficult to respond quickly and correctly. We often have late nights and very long days. Yesterday, for example, they decided in our project that we were going to have two major releases in the same day to two different environments, and it ended up with 4 of us working hard for about 12 hours to get both of those environments fully deployed and deal with all the problems that arose. And there are competing demands. We have the work that's been planned. We've got the production issues that come up that cause issues that we have to deal with. And of course, we've got unplanned work because the development teams or feature teams often come up with things that they weren't aware they needed in the beginning. Another concern or reason why we need to have good programming discipline is repetition. Nothing is done once. We have many, many things that we repeat over and over. One of those obviously is releases. We repeat those over time, and we'll have multiple releases of the same components. And we also will have multiple environments that we release to. So we'll typically, in our environment, we release to dev, to QAT, UAT. We have a performance environment and a staging environment, and of course, production. We also have hot fixes, which occur in our current release management process, occur on a regular basis so that we can somewhat manage when they were going to occur and get prepared for them and put them out. And the other thing that changes over time is the infrastructure. We often have to rebuild components, application servers or databases that need to be modified for one reason or another. And we're not talking about the code that's in them that's running on it, but the actual, maybe the scale of the service instance that's running, the kind of resources that it's on, up being the scaling up to handle larger workloads. Another thing is that we are constantly facing change. We have staff turnover, and this is a very important issue in terms of why we want good programming discipline. When we lose staff, we get new staff coming in, we need to quickly get them up to speed, and we need to have them be able to start looking at things and have things feel familiar as quickly as possible. Our business requirements change, so things that might have been the business requirements that towards the beginning of a project can change dramatically. One example is that you may start with a product or something that gets launched, and the initial target is that there's going to be a couple thousand customers, and then because it takes off, it's suddenly tens of thousands, and that changes the kind of requirements that you might have on the environment. The product architecture is going to change. So what the development teams may be working with a particular type of resource and decide that doesn't work very well, and they want to switch to something else. And lastly, our DevOps infrastructure of how we go about actually deploying and managing the environment, that changes over time. And since we constantly dealing with change, we need to be able to manage that more effectively. In order to achieve a high level of responsiveness and quality, which are our goals, we want to implement programming discipline because that mitigates the impediments to our goals. So let's talk about some of the things that we can do to do that will provide good programming discipline in our environment. There's two major dimensions of programming discipline. There's the process, how we do things, or the general mechanisms we're going to do, and then actions, which are specific things that we can implement or do to support the process. Working together, those are going to lead to a higher quality and responsiveness. Excuse me. The good DevOps practitioners use proven development processes. They don't go and try to invent something new. They go and draw on what other people have already proven to be successful. Often those things are modified for your environment, simplifying in some ways, adding in other things that are needed because you have specific needs, but it still starts with a well-proven development process because that will make your life easier. Some of the kinds of things that we do is implement a software factory where we have a single source of truth for everything. What we don't want to have is where we aren't sure what the source is for the code that's being deployed, or the source for our pipelines and our scripts and the things that we use to actually support DevOps. We also implement, as part of the software factory, the concepts of infrastructure as code, so that everything that is deployed in terms of servers, databases, all the basic components are all done as code, so that we can modify the code, redeploy them multiple times, and we're not having a manual effort of going through and trying to configure in our environments. The second thing is configuration as code, which is part of software factory, where anything that is a variable we put into configuration, and that becomes part of the code base. Again, we don't lose track of what the configurations are. It's not buried away in some change that was done in the cloud interface, for example, if you're doing cloud deployments, where you configure things maybe through a graphical user interface. Another thing that we do in our proven development processes is we use agile methodology for DevOps, just like the feature teams are using agile methodologies for their development work of the features that they're going to be implementing. We use it for DevOps itself. So everything that we do has a user story, and it's on our task board. The user stories have tasks. We set up peer reviews for work that is done. Peer reviews are very valuable, both as a training tool for newer people and as a way to just assure that when fatigue sets in or we have long days, that we aren't making silly or stupid mistakes. Even within our team, even those of us who are highly experienced and the ones that others, the people turn to for advice and support, we still have our work peer reviewed by somebody else. And I have had other people find stupid little things I did wrong, which are great because catch them, fix them, and you don't get burnt later. Another part of an agile methodology is that you must have living documentation for what you're doing. What you don't want to do is write up something or not have no documentation, which means people can't figure out what was done, or have documentation which is 2 or 3 years old and often can lead people astray. And associated with the living documentation is to also have knowledge transfer. So an important part of, as you develop new concepts and implement them in your DevOps environment, you want to ensure that the knowledge of it exists in multiple people. That helps to handle when you have staff turnover, it helps when people go on time off. You know, people do take vacations or get sick and you've got somebody else that knows it. Another good proven development process that we use is to make a clear distinction between release management and deployment management. We have a release management process that has well-defined stages, how you get from one to the next, and those are done on a regular basis. We separate that from deployment management. Release management is getting something ready for use in production or in some environment, and deployment management is actually controlling the deployment into that environment. And you can have a release that's ready for a particular environment, but be held off from actual deployment. An example might be that there's a new capability that's ready to be deployed into the business, but we're approaching the end of a fiscal reporting period, and the business says, yeah, it may be ready, but don't deploy it now because we put too much risk on what's going to happen in this week, and do it 2 weeks from now. So we separate that release management and deployment management for that reason. And part of a good proven development process is to keep in mind that if something needs to be done, we should script it. It should be code. What we want to do is avoid having anything that is more than maybe a single click be something that requires typing a lot of things or clicking on a lot of things in a user interface. This is an example of one of our user stories that I've disguised a little bit to so that it's not to keep it hidden from who our client is in this particular case. But it shows an example of a user story, which you can see on the left side, and then associated with it is a series of tasks that have to be done. We have tasks that are already done in the right-hand column, those that are active in the middle, and ones that are still to be done on the left. And we keep track of those with hours for each. And one of the good reasons for keeping track of time it takes per task is that when you do this type of user story again, you will have a better handle on how long it's going to take to do it, and that can help guide your clients. Another thing that we find very useful in terms of our processes is to script the creation of recurring user stories and tasks. So we've actually put together, in our environment, we use PowerShell as our scripting language. We've actually put together some a PowerShell script working, and again, this environment is in Azure DevOps, that goes and using some templates and some parameters that are put on a command line, it goes, creates a user story, creates all the tasks that need to be done, and inside the task actually goes and fills it in with work that's to be done, so that we have almost a cookbook approach. We can generate the user story and the task, and then hand them off to people where there's step-by-step instructions of what needs to be done as a reminder. It provides good guidance so that even those that are experienced and those that are less experienced will know what to do and be able to follow it. And that leads to higher quality of results because you don't have missed steps or steps being done out of sequence. We do this in addition to creating actual run books for our deployments, which deal with the details. You can see there's one of the tasks in there is to update the run books. Those run books then become the details of all the steps that must occur during a particular deployment. As I mentioned earlier, static documentation is not worth anything. If it's outdated, you can't rely on it. If it's incomplete, you can't rely on it. You don't have a way to train new people or anything else. So what you need to do is have a way to have living documentation. One of the things that I've found over the years is that you cannot maintain documentation in two places or more. The reason being that as soon as you try to do that, have something in two places, at least one of them will be wrong. And in most cases, all two or more of them will be wrong. So what we try to do is have documentation be in some source and then use that to generate other things that we might need. So an example of what we do in our environment is we use the documentation capabilities that are in PowerShell to document each script. Then we have a script which takes all of the PowerShell scripts that we've created and automatically generates wiki pages from that with all the information about each of the scripts. This has some great benefits like consistency in documentation of how it's going to look and how you're going to see it. And if you also enforce the standards of how scripts should be documented, you're going to have better overall documentation. In our environment, we actually update this daily because we have scripts that are changing on a frequent basis. If there's a major change that we want to get published, we may actually put it out sooner. An example of one of our auto-generated wiki pages is shown here. We have process blocks that can be called from the scripts. And the auto-generated page has got a table of contents that points to all the scripts so they can be easily found there, as well as being searched for. And then within the block, we have a statement right up front of when this was generated so people can see how current it is. And this, this, as I said, updated normally daily. And then it begins the actual documentation. And what you see in the gray at the bottom is the beginning of the actual documentation comes directly from PowerShell. And we just capture it and embed it. So this is a great way to keep it living, keep it current, make it searchable. By doing this into a single wiki page, you can search the wiki page for scripts that do a particular type of thing, find them, and find the one that you want to use and go from there. So we've talked about the processes that we want to have in place, and now we want to focus on the other dimension, the actions that we need to define to support the processes. And the actions fall into the categories that I'm showing here. The first one is standards and guidelines, which basically are the rules by which you would do scripting or creating pipelines or anything else that you're going to try to create. Just as if you're developing developing code, a feature code, there are usually standards and guidelines for naming conventions, for how various modules should be structured, what kind of standards should be applied, what conventions are to be included, what's going to be put into every component that's created, those types of things. And we want to do the same thing for our scripting language. We'll show that we'll show some of those, an example of some of that in a minute. One important thing we find to make it easier to create and maintain and have knowledge transfer and everything else is to have boring consistency. By that, I mean, everything looks the same. Everything is done in exactly the same way. If you pull up any two pipelines, they are going to look exactly the same, except for the details to deal with what is being built or what is being deployed. It's not every person for themselves doing their own approach to how they want to create it. It's all based on doing a standard set of things in a standard way. That has the benefit that if I want to bring in someone new, I can give them a small amount of training, show them one or two scripts, show them one or two pipelines, point them in another one, they're going to open it up, look at it, and it's familiar with them already. And that helps. We also, and we talked about this earlier, that we want a single source of truth. We have the same thing that we want to maintain in our DevOps environment. We want to have a source of truth. We want a source of truth for all the branches, for all the pull requests. We put those into our source of truth, branches and pull requests, so that we can maintain what's there. We can back out changes that were put in that were wrong. And we have it do this in a repository. We also have a well-defined structure for our build pipelines, the CI pipelines, and the CD pipelines, the deployment pipelines. Our approach is to use task groups or templates, which allow the pipelines to become, in a sense, almost like a Lego set, where if you want to create a pipeline, you create the shell, and then you put in the Lego pieces that you need in a reasonably well-defined order that makes it work. We also, another thing that we do in terms of our actions that helps is that if we're creating scripts, we always create them in pairs. So if we create a script to create something new, we create the script that would remove it, because we know from experience that if we create something, we're going to have to tear it down or remove it and rebuild it again. So it's better to do the two at the same time. One, it allows you to actually test your new creation, do it, remove it, go through that a few times to make sure it works, and then have it available when you need it. We've talked about that there should be standards for the selected DevOps language. One of the standards and guidelines should be that all scripts are written in the same language. This is an issue of how do you support stuff if you have some scripts in PowerShell, some in Python, some in Perl. Very soon, you get to the point where if you bring someone new on, they take too long to learn how to support everything. If you go with a single language, then it's a lot easier to get people trained and up to speed. We have, and this is an example from some of our standards, we have standards such as, what should be at the beginning of the script, on how to use commandlet binding, for example. We do some specifications so that anybody creating a script has the guidance right in front of them what to do. And people that are doing the peer reviews use this same set of standards and guidelines to review the scripts to make sure that they actually meet our standards and our needs. Going back to the boring consistency, we've talked a little bit about this, but I wanted to go into a little bit more. The documentation should be the same. So we want the documentation in every script to follow exactly the same format. So if I'm looking for certain types of information, I'm going to find it in the same place in each, script that's being created. We have our standards, which you saw on the previous slide for commandlet binding, how we want to use that. We have standards for parameters. So one of the things that we do is we ensure that that a parameter that has a particular purpose is the same name in every script. An example, in the Azure environment, we have a key vault. So the parameter name that's used anytime we need to pass a key vault is key vault name. Always spelled out, always the same capitalization. And we can go through any script. We're creating a new script. We know what the name is going to be. If we're going through searching for all usages of it, it makes it very easy to find every place that a key vault name is referenced. We have standards for how you should start a script. So we do initiation of a script, certain code always goes at the beginning. We have standards for how you should do your logging, common functions and ways of doing that, common ways of doing error handling. If we're creating a function, we have a standard return for a function so that all functions return an object that looks the same. And if we're terminating the script, we use the same code at the end in all the scripts. Again, this goes, as I said, boringly similar. They all look the same. I can look at any two scripts and I know what to expect. And all I need to focus on is not the structure of the script, but the meat of it, where it actually is doing the processing that is important. Here's an example of some of our structures that we have in place. We have, for example, at the beginning, the first couple lines of every script is to import all of our standard functions, the DevOps module. To initialize a script, we actually have a standard initialization for all scripts so that they're done the same way. And most of our scripts end up using REST APIs to get to things in Azure DevOps. And because of that, we always start off with creating an authorization header so that it's available and we use it in the same way. When we process errors, we do things like use common functions to handle the error message so that all scripts that report an error report it in the same way and take the same action. And if we need to change the action, in this case with stop process error, if we need to make any modifications to what it does, we have one place to change it. We can change it for all. We actually had to do that recently where we wanted to handle a special case where we could cause an error message to appear or an error to appear in the pipeline without actually fatally terminating the processing flow. And because the stop process error is used everywhere for terminations, we were able to actually change its logic and fix everything at once. We also, as I said, we have a common function return. So if we're returning from a function, we always return a tuple, which we've got coded as a PowerShell object type, and it contains a Boolean flag of whether or not the function succeeded or not. So if it is failed as true, it failed. We have a string array of output that the caller can choose to display or not. And if it succeeded, there's also results, whatever the results are that would normally be expected. Taking an approach like this means that we don't have to have each individual script worry about how to handle returns from functions or worry about what function it is that's being called and what it's going to return. They're all the same we can handle them all in the same way. As I mentioned before, we want a well-structured single source of truth. So we maintain all of our DevOps code, all of our DevOps pipelines, everything are maintained in a Git repository. We use a fairly simple directory structure. We try to segregate the folders for usage. So we may have a one-time folder for things that are done only one time. They're just kind of, they're there, so we have them for reference. We might have a things for manual ad hoc that we might want to do. Then we have our main folder for the scripts that we use in all of our pipelines that are done frequently. We try to keep the directory structure relatively shallow because you don't want people searching through multiple folders to try to find something. You want to make it easy to find something and yet have enough structural depth to allow people to segregate things and keep them separated. Another important thing that to help make your DevOps environment work and have a better programming discipline is to have identical tooling for everybody that's on the DevOps team. This means that everyone uses the same tools, the same versions of the tools, the same things are installed. In our environment, we have, for example, everyone's using DevOps is using Visual Studio 2019. You can see some of the other things that are here. We actually go further than this. We have certain things that are on each person's local machine that are structured. There's some of the directory structure that are standardized so that we can actually go, if I have to go and look at somebody else's system to see what's going on, I know exactly where to look for finding certain types of things that might be needed or that might be missing. Doing all of this helps save a lot of time because I don't have to worry about someone installed has the wrong thing because I know they're all using the same tooling and the same structures. Excuse me. Thank you. So we've covered the why, and the why is that we want to have higher quality, better response time. We've covered the what, which is the whole idea of what are some of the things that we need to do. It's not an exhaustive list, but it gives you a feeling for it. So now the very important thing is, how do we do it? The first thing that people often bring up is that, well, we've got a lot going on. I don't have the time to do all of this and get all of this in place today. And the answer is that's absolutely true. Nobody can create this for an existing project overnight. It's going to take time. So there are ways to make this happen in a controlled, manageable way that's going to benefit you immediately and long term. So what we do is we implement good programming discipline in manageable steps. The first step you have to do is you do have to adopt a DevOps culture. And that means not just your team, but the entire organization. And this is from all the feature teams, the developers, the business, those responsible for production deployments, production support. Everyone has to adopt this understanding that DevOps is a multidisciplinary environment, that it's bringing together these people and skills as co-equals to better support the business. The second thing that you want to do is you always want to start small. So if you have an existing environment already, pick one item that you can see some immediate benefit of getting it put in place and start on that one. First thing you do as you get started on it is you write some initial standards, but they aren't final. They will evolve over time. So standards and guidelines are living documents in and of themselves, and you add things to those standards as things come up. So You'll find that today, you encounter a new type of issue and you say, going forward, we should standardize where we do this in a certain way for everybody. And so you add it into the standards, and all new things get implemented in that that manner. We also need to revise the architecture and design of DevOps as requirements change. We talked earlier about the idea that you could have requirements change from the business, that they start off with thinking something's a relatively small customer base, and then it grows, and that might drastically change the infrastructure architecture, might change how things are connected, how they have to work, and that directly is going to impact the pipelines, sequencing, how you do deployments. So you need to revise that as you go, as those requirements change, or as you incorporate more things into your evolving disciplined programming. You tailor the programming discipline to your organization's needs. This is something that's very important. There's a lot of tendency to go pick something up that may be seen and say, I'm going to implement that. But you need to take it in and take the realistic approach that not everything in what someone has put out there and published meets your organization's needs. You may not have some of the skills that are needed. You may not have the financial depth or the number of people. You may also have a more complex environment, or you may have certain security requirements that are not part of what you've seen there. You tailor it. You want to take it with an approach on anything that you try to pull in and use of simplifying it to the point where you still get the benefits that are there, but you've done sort of the minimum essential things for your environment. The last thing that you want to do that you should need to do in order to make this manageable is update anything you touch. So if you go to modify a pipeline, for example, to make a change to it, you should at that point go through the list of all your current standards and guidelines, and if anything's not conforming, take the time that you're touching it to do those additional updates. This morning, for example, I found a case where we had some technical debt due to some duplication, and there was a pipeline to be modified that ran into that buzzsaw, and it took an extra 20 minutes to go and actually get rid of the duplication, get rid of the technical debt, while updating the pipeline in the way that it needed to be done. Was focused on it, was able to get it done. I've now reduced one component from what we have to manage long-term and made things more consistent, so it'll be easier to teach people going forward what we need to do. This kind of ties it all up. It's a very manageable thing to implement good programming discipline in your organization. You just need to start off with getting the understanding why you want to do it, improve your quality and improve the responsiveness to your customers. You need to understand what needs to be done, the actions and processes that are important for your organization, and then you need to go and implement the how, do it in manageable steps. And with that, I'd like to open this session up for questions.
Hey, Brad, thank you. We have a couple of questions in the chat. I will read them to you. So, first question from Emil. 12 factors methodology states that configuration should be managed separated by the application code. You mentioned earlier that the configuration should be written along with the code base. Which code base should it be? The application microservice code or the environment descriptor code?
The answer is yes. And I say that a little facetiously. There's where the configuration code needs to exist is it's kind of one of those things that is a religious war. Everybody has their opinion about what is the perfect answer. My opinion is that if you do your configuration code the way it should, some of the configuration code is application related, some of it is kind of infrastructure slash, not so much infrastructure, but the connection, the system related. If you try to separate those out into two distinct things, you end up with them potentially getting out of sync. So from my perspective, it's better to have one with all the configurable, one code base with all the configurable information. Keep it separate from the code, its own repository. So in our environment, we actually have one of our repositories is the configuration data. People have access to it to update it, but it contains the information that configures individual applications as well as that configures the overall system. And it's a balancing act. Again, this is where you tailor it for what's going to work best for your organization, your project. Very small projects, you might have that just as part of maybe in a separate folder, but inside a single repository. Large projects definitely want to separate it out, and you just need to decide who has control to be able to approve changes in it. Not necessarily make changes, because those could be feature branches that would be someone who implement a set, I have a change to do and a PR, but who approves it should be people that can look at the impact that that change might have. Next.
Great. We do have other questions. So one from Julian. Do you document and send to wiki bash scripts too, or is it only possible with PowerShell scripts?
In our environment, we aren't using bash scripts at the moment, but it's doable. I have done that in the past. Every scripting language that I've worked with has an ability of some sort to do documentation. Some of it are more well-defined than others, but even if you have one that, let's say you're working with a language like, okay, let's say you're using the old Windows .bat shells commands, which have no structure to them all. You still could define a structure and say the beginning of every bat script is this set of comments, which are commented out, and those are your documentation. So you choose what it is, and then you just standardize the form for it so that it's the same across all of them, and then that makes it easier for you to go and generate the wiki documentation from it.
Great. Last question we have from Travis. I've recently been bitten by Azure Key Vault outages. When using configuration as a service, does that service become a single point of failure we've worked to eschew by moving to microservices? How do we make configuration highly available?
Always a good question. That's in part, it means that you need to have an infrastructure and an architecture that is oriented towards the types of resilience that you need. Some of that is picking the right tool for things like Key Vault. So in Azure, Azure Key Vault has some great capabilities. It also has some restrictions that are put on to basically prevent one customer in the Azure world from taking things away from everybody else that's out there. So you have to look at how that works and then maybe use a different tool for key vaulting, and there are some other tools that would get around that, or you can do things that that really deal with putting the right, putting in caches where it's appropriate in the architecture to reduce the load on the key vaults and make that so you don't get those kind of outages, and have standard code in every feature team's code that reads from the key vault to handle outages in a well-defined way. So one example would be that every service that runs and starts up, it caches certain information itself. It periodically goes and probably tries to refresh it, but If it can't get to the external key vault or cache to get to it, it relies on its fallback information and uses that. It allows you to continue to run maybe in a degraded manner, but it's one way around that. Again, that comes back to it's an architectural issue. DevOps can support that, but it's a matter of the application or product or system architecture to really take that into account and make it work right.
Great, thank you. We don't have any more questions.
Okay. It's been my pleasure to talk to you today. If you have any questions, please, you can email at me at the address that's shown on the last slide, and I will endeavor to answer that as quickly as I can. And I hope you stay tuned for the rest of Programmers Week and enjoy the rest of great presentations that we have coming your way.